Now, the clustered indexes and non-clustered indexes we talked about before can also be unique. You can also have a unique constraint on its own. Basically, what that does is you say, I'm going to choose this column or this group of columns. I want it to be unique. And what that means is, let's say, using the 3 examples of the query we just looked at, account ID, display name, reputation. I don't want those 3 to, there's no chance those should ever be not unique, because, well, account ID will be unique. So you could create a unique index on account ID. And what that will do is if somebody tries to insert a duplicate value into that, it will throw an error. Because you get errors, you'll have to be aware of this when you're writing queries. You'll have to speak to developers. You'll have to let them know that there's some logic here. If they're .NET, you'd have to do try-catch blocks, etc. But it will just enforce that at database level. You cannot create duplicate indexes of this field or these group of fields. If you create that, a unique constraint on a clustered index, then we create the primary key for the table. And it's, instead of just creating a clustered index, you create a cluster primary key. And again, that could be one or multiple columns, but that's what it's called when you do it to a cluster. For a non-clustered index, it's just when you do your creation script, there's a unique in there. Create unique non-clustered index instead of create non-clustered index. It's a very simple change, very useful for data control. Okay, so filtered indexes. These can't be clustered. These are always non-clustered indexes. And effectively what it is if you're querying data, on the creation of the index, you can add a where clause. Say you've got an orders table in your environment that contains your history of orders since forever. You've got 5 years worth of orders in here. Orders are constantly being modified, being sent out, and you're constantly querying for open orders which aren't in a status of closed. Then what you can do is you can create a filtered index where status is not closed. And what that will do is, instead of containing all the rows in the underlying table, it will only contain the relevant data. That could be useful for things like orders. There's many other use cases, but it's a way of reducing the amount of data you're searching through in order to make your queries more efficient. There's a few gotchas with filtered indexes. If you are declaring a variable with that I want to return a top 1,000, or in my example, where reputation is greater than 10,000. If you declare that as a variable and use a variable in the query, it won't work. It has to be an explicit value. The way around that is by creating it in a block of dynamic SQL, which again, we won't cover here, but you effectively push a predicate into the SQL and execute the block of SQL with the explicit value in there. So 10,000 rather than at reputation. We've got an example of it here. So here at the top is the query. I want to return the display name and reputation of all users where reputation is greater than 10,000. And I also want to order it reputation descending. So I want the people with the highest reputation at the top of my list. Now, at the bottom, you can see the index that I created here. And it's indexed on reputation and includes the display name, because we're not searching using display name, we're searching using reputation. That's the predicate. So that's what we want to index. We're just returning display name. It's along for the ride. We can just include that in our index. But the filter looks for reputation is greater than 10,000. Now, on the left here, you can see the duration, 280 milliseconds, and it does our 86,000 reads. That's the whole table. It's scanning the entire table. And if you look at the execution plan, if you're not too familiar, on the right of this execution plan, you can see our table scan, and that's scanning the entire table. We're then having to sort the data because I've asked for it descending. So we have to sort it. And then because it's such a big query, it went parallel. So we have to gather the streams before we return the data. Now this, of the two, was 100% of our query cost. And we'll cover this later, but you can see in green, there's a non-clustered index it's asking for, which is going to improve the performance by 92%, it thinks. We'll come back to what that green bit means. But I created this index, and now we just do a scan, and you can see the index name here. We just scan that index. Now, it's exactly what we want. I've used a hard predicate, and it's already sorted. Now, it doesn't matter. The index is sorted ascending. I've asked for it descending. Doesn't matter. As long as it's sorted, SQL can do a read from the end on the index as well as a read from the beginning. So that doesn't actually matter. But you can see, again, on the left, 86,000 reads, on the right, 60 reads to return all this data. That's just much more efficient. It's less disk, less memory, less IO. It's a no-brainer when it comes to select queries, although there is a balance, and we'll talk about that later. So if you can use filtered index to solve a particular problem, absolutely bear that in mind. Next type of index we'll talk about is column store. Now, most indexes are stored at a row level. So you insert a row of data, it stores it as a row of data. What column store does is fundamentally stores that differently. Now, you can create this. I mentioned clustered indexes earlier. You can create a clustered column store, which again fundamentally changes how your data is stored on disk. You can also create non-clustered. But what this means is the way the data is stored is it creates row groups. When you create a column store index, it creates row groups, which is roughly 1 million rows of data. And what it does is it takes 1 million rows of data and looks at each column and tries to compress them. This is great if you've got a lot of repeated data. We go back to the orders table. You've probably got item number or barcode number or anything like that, an item identifier. You've probably got a price. You've probably got a status. Those, you'll only have a certain amount of those. They will compress really well. I went to a client not too long ago. When I went in, they had a history table, which contained a history of data going back a number of years. It was 450 gig. I applied a cluster column store index. It took it down to 14 gig. As long as your data is compressible and you can take advantage of this, it's a fantastic tool for certain situations. The downside of this, it's more difficult to access the data you need at times, and inserting new fresh data in there comes with its own idiosyncrasies. What it effectively does is when you either create the column store or when you rebuild the column store index, you'll have a fresh set of row groups. It'll take everything, it'll sort them correctly, and then it'll group them up, and you'll have however many row groups for your volume of data. Any new data that gets inserted into there, that gets updated, that gets deleted, goes into what we call the delta store, which is effectively kind of a sub row group of uncompressed data. And that'll sit in there until you rebuild the index, until you do some sort of maintenance, and we'll cover maintenance later. But for fresh data, it won't take advantage of the column store until you do a full rebuild, which is not a free process to do in SQL Server. And that's not a monetary term. That's a hardware and CPU term. Rebuilding any sort of index comes with a cost on hardware and resources. It's worth noting that if you do very large inserts and you're inserting more than 1 million rows, it can create a brand new proper compressed row group and just put that in. There's edge cases, but yeah, there's gotchas with it. It's very useful when used correctly. It's something we've used extensively here at SSG. And if you come across any of these indexes and you get into trouble or you're not sure or you're coming across some of these gotchas, stuff I might not have even had time to mention in this hour, then by all means, just reach out to us. We're always here. We're always happy to help. So yeah, this is column store indexes, usually used for things like data warehouses where you're loading in loads of data overnight or you've got a lot of history. Very useful in the right circumstance.